Welcome to the trig review of the century. Listen, we're going to go through trig today. We got some Pythagorean theorem to go through a little bit here, and then we're going to be talking about Sohcahtoa, which we'll get a lot into tomorrow. For homework tonight, you're basically going to need to know a lot of the this part down here. So we'll talk about this one first for tonight, and then the trig functions, and then we'll get to the other ones a little bit later in today. So we're going to start there. So we're going to jump around the worksheet today a little bit. So let's go through the first one with Pythagorean theorem. So remember, one of the options with Pythagorean theorem is it's got to be a right triangle. You have to know two sides and look for the third. And if you are, then you can use the formula. So remember, you got a squared plus b squared is equal to c squared. You can also do b squared is equal to c squared minus a squared. And then don't forget the fact that you can also do a squared plus b squared bigger than c squared. If the a squared side wins, that's an acute triangle. And if the c squared side wins, so if a squared plus b squared is less than c squared, the c squared side wins, that's obtuse. Those are the two main corollaries that come off of the Pythagorean theorem here. So, okay, first one. Two campsites located opposite each other on the shores of Lake Omega. Shown in the diagram below, Sam's position is S. The distance to the campsite B is 1,300 and to A is 1,700. So what we want to know is what's the distance from A to B. So that's Pythagorean theorem. We're looking for a side. We know two others. So here we can use, because we're looking for a leg, we can say that x squared is equal to, and this is the 1,700 squared minus 1,300 squared. So we can use that formula here. If we bust up the calculator again, 1,700 squared minus 1,300 squared. And it says nearest yard, so we're going to get a decimal here. And it's 1,000,000, looks like 200,000. All right, and then we'll take the square root of the answer, and we're going to get, and then nearest yard would be 1,095 yards. All right. The next question is a tricky one. Okay, so we have the diagram. We know that this is a right angle at D. We have AD, which is 5 radical 2, and AB is 2 radical 15, and we want to know the length of BD. And we've done this question a few times, just to recap. If you are using Pythagorean theorem again, and we can do x squared is equal to the diagonal, the hypotenuse is just 2 radical 15 squared minus 5 radical 2 squared. And if you were to type this in the calculator, okay, we just want to point this out. First of all, when we square something, we multiply it times itself. So let's just do the 2 radical 15. So 2 radical 15 times 2 radical 15 is 60. But if we just do 2 radical 15 on the calculator, right, with the squared, let's actually move that out here. We only get 30. What the calculator is actually doing here is it's only squaring the radical 15. So it's actually doing 2 radical 15, right, times radical or square root of 15. And that's what it's doing. Instead of doing, right, the 2 radical 15 times 2 radical 15, it's only squaring the radical 15. So to fix that, we need to make sure that we use parentheses, okay, around the radical, we're squaring the square term, which is the entire 2 radical 15 and 5 radical 2. All right? And so when I do that, we do parentheses 2 square root of 15. We know that this is going to come out to be, and then squared is 60. And then we can do 5 square root of 2 squared, and that's 50. So this is really just 60 minus 50. So x squared is equal to 10, and then x is equal to the square root of 10. And so those are the choices here, okay? All right. Now, let's talk about Sohcahtoa here. We're going to do this one next, and then we'll jump a little bit in the book here. So Sohcahtoa is literally just the ratio of the sides of a right triangle, okay? We use the Greek letters theta to relate the missing angle here. Now, whenever you're doing trig, you need one side, one angle, and then you're looking, right, for the other side or angle. Say missing, right? So essentially, it's using two sides and two angles. Okay, Pythagorean Theorem's got the two sides looking for the third. This is using two sides and two angles. You need a side and an angle, or two sides looking for the angle. Be careful here, okay? That's why you don't like to necessarily phrase it like that. All right, the three basic trig ratios are sine, and remember, sine is the opposite leg over the hypotenuse. All right. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite leg over the adjacent leg. And so when we're doing a question, we kind of want to break this down into three parts, right? Number one, we always want to label our sides. Well, actually, we want to find our reference angle. That's the angle that we're using. E-F-E-R-E-N-C-E, reference, right? I'll spell that right. Angle. What angle are you actually using in the question? Okay. Two, you want to label your sides. And we're going to use opposite, adjacent, and hypotenuse. You want to pick your trig function. That's sine, cosine, or tangent. You want to plug in and solve. And remember, we're using the inverse for angles. If it's sides, we're going to cross multiply and solve. Okay? Inverse is for angles. That's essentially the procedure here. So if I am using this theta and I have these two sides, opposite, adjacent, then it's going to be tangent. And remember, what we use for this is that that word Sohcahtoa, right? Sohcahtoa. Or you remember how to spell it and how to write it, and that we're using the fraction. Okay? So the sine of my angle is equal to the opposite over the hypotenuse. Cosine of the angle is equal to adjacent over hypotenuse. Tangent of the angle is equal to the opposite over adjacent. We're going to get to this. We're going to come back to it. Right now we're flipping to page 3. And we're going to head on down to the bottom here. Okay? This is what you need for the homework tonight. Important fun fact. When A or B are complementary, so A plus B equals 90, then the sine of A is equal to the cosine of B. All right? So let's pick two numbers that are complementary. Let's choose 50 and 40. So the sine of 50, not 54, but 50, okay, plus the cosine of 40. Actually, that's not what we want to do. Don't do that. The sine of 50 and the cosine of 40, you're going to notice are the exact same number. They're equal. As long as these two numbers add to 90, that will always happen. So if you want to do sine of 20 and cosine of 70, you're going to get the same answer every single time, as long as they add to 90, and that's the important factor. So, which expression, here's two questions, is equivalent to sine of x when x is in between 0 and 90? So keep in mind that coming off the right triangle, this is x, right, the sine of x, okay, the cosine, so sine of x, is going to equal the cosine of y, which is this angle, when x plus y are equal to 90. Okay? So which of these things is going to use the fact that this is 90? And if you look, if we're looking for y, if you solve for x, we're going to get y is equal to 90 minus x. And so that's the function I want to choose. Okay? They have to add to 90. Second part. When instructed to find the length of HJ and right triangle AG, HJG, and I'll write the equation sine of x is equal to HJ over 20. Marlene wrote cosine of 20 is 62 is equal to HJ over 20. Are both students correct? Explain your answer. And so what we want to do here to really use this explain part means your use of words, is let's talk about what the ratios are, right? Here's HJ, we can call that x, and this is my angle. So this is the opposite. This is the hypotenuse. And so the sine of 28 is indeed equal to, right, the cosine of what's the complement, right? What's 90 minus 28? And so if you do that, you should get 62. And so this is what this angle is. So it's equal to the cosine of 62. Okay? So if you actually do, we can say that. We can say since 28 cents. All right. Sorry, guys. We're going to make some room right here. Down on the bottom. You guys see this? Move it down, right? Since 28 plus 62 is equal to 90, then the sine, we're going to say, of 28 is equal to the cosine of 62. Okay? And then we just want to say, so on top of that, right, the sine of 28 is equal to, actually, we don't need to say that. This is true. The sine of 28, right, is hj over 20, and the cosine of 62 is hj over 20. So, since both the sine of 28 and cosine of 62 are hj over 20, both students are right. And that's it. We want to relay the fact that they add to 90, and therefore the sine and cosine have to be equal. And if the sine and cosine are the same thing, then the students are correct. That's all we're doing here, okay? I'm just going to check out the back real quick to make sure and there isn't anything else. That's what you really need for tonight for homework, but we're going to keep rolling through this. So part 2 of the video. Here we go. All right. A man was parasailing above a lake at an angle of elevation of 32 degrees. Remember, angles of elevation. Actually, what am I doing? I'm way over here. In right triangle shown below, what is the value of x nearest whole number? So here we're looking for a side length, okay? So we're finding our angle, right? Two sides in an angle. We're finding our angle. We're labeling our sides. This is adjacent. This is hypotenuse. And this is opposite. We're drawing a Sohcahtoa in there. And I'm picking now the cosine because I have, the cosine because I have A and H. So the formula is the cosine of the angle is equal to the adjacent over the hypotenuse. And then I just plug in. So cosine of 30 is equal to x over 24. And then we're looking for a side, we just cross multiply. So it's 24 times the cosine of 30 is equal to x. And then be careful when you do this on the calculator here, okay? Remember that as you're doing this on the calculator, if you do cosine 24 times 30, the calculator thinks you're doing the product of the angle and then the cosine of it. Be careful, that's not what we want. We want 24 times the cosine of 30. And so that is our nearest whole number, would be 21. All right? Angles of elevation, remember, if you are standing at the bottom of our tower, when you look up, you create the angle of elevation. Or depression, it doesn't matter. Depression is from the top down. We always want to put the angle of elevation and depression in the bottom corner. So in the diagram below, we have the building casting a shadow of 72 feet on the ground. Remember, shadows are on the ground, people, not the diagonal. Okay? What's the angle of elevation? We want to know how tall the building is when the angle of elevation is 40 degrees. So once again, two sides, right, and an angle. So there's our reference angle. This is opposite. That's adjacent. And so we want to do the tangent of the angle is equal to the opposite over the adjacent. Okay, so tangent of 40 is equal to x over 72. We're going to cross multiply. 72 times the tangent of 40 is equal to x. And then we're just going to bust out our calculator. Make sure I'm in degree mode as well. And we're going to get 60 degrees. So remember, in your calculators, if you scroll up in the corner here where the battery is and hover over the battery, it'll let you know if you're in degree or in radian mode. You can actually click it and then go to settings and change it. Okay? And if you do change it, remember to go down to make default and set it for default. Okay, so we have once again, we have an angle of elevation of 32 degrees. That's in the bottom corner of our triangle down here. Okay, it's modeled in the diagram below. How many meters above the lake? I'm looking for this side right here. So here's our angle. We have the opposite side and the hypotenuse. So if you need to do Sohcahtoa, we're using O and H, and then sine. Remember, the sine of the angle is equal to the opposite side over the hypotenuse. So the sine of 32 is equal to x over 129.5. And this is the other scenario. Here we were always looking for the number on the top of the fraction. So we cross multiply, you're done. If the number here is on the bottom of the fraction, when we cross multiply, right when we're going to also be down here. If it's on the bottom, right, when we cross multiply, we're going to have to divide out one more time. So we cross multiply here, we have x is equal to 129.5 times the sine of 32. And then we get our answer just by multiplying those two things together. And we're going to the how many meters, and it's 68.6. And so that's choice one. Okay, by law, the wheelchair of service has a ramp may be inclined no more than 4.76 degrees. So 4.76 degrees. If the base of the ramp begins 15 feet from the base of the building, this is our 15 feet, okay? Which equation can you use to determine the maximum height h of the ramp entrance when it reaches the building's entrance? So if we have this setup, right, we have the opposite side and the hypotenuse. Now remember, you're 15 feet from the building, so it's not the length of the ramp, it's the distance from the building. That's the bottom here. And that's the difference between sine and tangent, so be careful. We're going to do the tangent of the angle, right? We could use theta for this if we want, is equal to h, right? This is the opposite side. We'll just do OPP, right, over h by p. So tangent of 4.76 is equal to h over 15. And there's our answer right there. Okay? The last guy down here in right triangle, which equation is true for this triangle? So if we used, you can see it's got sine of A, tangent of A, cosine of A, and sine of A. So we're always using this angle. I can tell that from the answers. All right, remember that side is always across from the angle. So this is my opposite. The one attached to it on the bottom is the adjacent. And the longest side across from the right angle is the hypotenuse. So, Sohcahtoa. And then that looks like a good deal, people. All right, so now you're going to do the sine of A is equal to, and it's opposite over hypotenuse, A over C. And so if we cross multiply, right, what will we get? We get C times the sine of A is equal to little a. And if you look, C sine of A, ooh, there's one. So this is true. But let's keep going. What if we did cosine of A, right? The cosine of A is equal to the adjacent side, that's B, over the hypotenuse, C. And if I cross multiply here, so I'm just going to box this in so we don't get lost here. I'm going to get, right, C times the cosine of A is equal to B. Look at C, cosine of A equals, oh, hey, it's supposed to equal B. So that one's out, okay? And then if I use tangent, the tangent of A is equal to the opposite side, A, over the adjacent B. And if I cross multiply, it's going to be B times the tangent of A is equal to A. And so you can see it's B, oh, this one's C, so we know that's out. So our answer was not B sine of A, but C sine of A, and so that's before it. You're doing the proportion, and then you're cross multiplying to solve. Okay, finding a missing angle. Remember, we need two sides. So two sides, and you're looking for the angle this time. So two sides in an angle. You're still going to do the same thing, right? You're going to identify your sides, find your angle, it's right here. Identify the sides, that's the adjacent, that's the hypotenuse. Pick the trig function, okay? Plug in, And this time, instead of doing the cross multiply, you're going to do the inverse. So identify cosine, make my trig function, I take the cosine of both sides, and I have my answer. Okay, remember on the calculator using that trig button next to the, I believe it's the number 7. Yep, okay. So let's do the first one. Find the measure of C to the nearest degree. So once again, there's our angle, opposite and adjacent. So we're going to do the tangent of C is equal to 14 over 29. And then we're going to bust out our tangent inverse of both sides. All right, and so C is equal to, and then I'm going to use my calculator. Now in mine, you're going to press the trig button, you're going to go select it. On mine though, it's just using the tan inverse. And then I put the fraction in, so 14 over 29. And then we round accordingly, nearest degree, so that's 26 degrees. All right, communications company is building a 30-foot antenna to carry a cell phone. Transmissions is shown in the diagram below. A 50-foot wire, so that's the hypotenuse, from the ground to the antenna is used to stabilize. We know that this is 30 feet tall. What is the measure of the angle the wire makes to the ground? Wire to the ground is right here. We can call that theta. So once again, I find theta, I label my sides, opposite, hypotenuse, pick my trig function, Sohcahtoa. And we're going to pick sine because we have opposite hypotenuse. So sine of theta is equal to opposite 30 over hypotenuse 50. And then once again, we want to get rid of sine. We don't want to cross multiply. We want to get rid of sine. So we're going to do the sine inverse. Now, for you people who don't like writing sine inverse every time, you can just put down theta and then show the work is equal to the sine inverse, right, of 30 over 50. So what we're not showing here is the sine inverse of sine theta. That's what we're not showing, that part, okay? And then I'm going to take my calculator. I'm going to bust out sine inverse 30 over 50, and there's my answer. And it says nearest hundredth of a degree. Hundredth, remember, is two zeros and 100, so the 2 decimal places. 6 is going to go up, so it's 36.87. And that's degrees. All right, last part. Law of sines. Remember the law of sines. Actually, I'm going to do a special video for this one, so I will send this one out a little bit later. Just take a look at these two today, and then I'll send that one out for